Welcome, guys. We saw like arrays how it works theoretically, and also we saw how the memory representation of arrays, how to access it, what is the time complexity for insertion, deletion, modifying an elements in an array, and also we saw the space complexity discussion. So, as part of this session, we will talk about practically how we can do the operations on array, operations like accessing, insertion, deletion, and modifying. Right? Okay, let's start. So include IO stream to just see the IO operations like printing elements and all. Namespace, std. Okay. So now we'll start directly in the main. In the main function, we'll see like how we can declare an element array uh, in an C++. So declaration, ration, and initialization. There are different ways you can declare array. For example, you can declare like a integer array of 5. This is one kind of declaration, and another one is array without giving any size. You can try to give some size like this. This is also one kind of declaration. Size will be automatically calculated. Another way of declaration is like you can declare and you can initialize also. Okay, so let us follow this last one. Okay. So this is there are three ways we can declare arrays in C++. This we will just follow the last one. Okay. So what we can do, how to access an element. So, okay. Uh, Generally what we can do is if you know the index, then easy to access an element. If you want to access elements, you should know the index of the element. Okay. Index of the element in an array. For now, what we will do, we'll try to access all the elements first actually. We'll try to print this. Okay. So I will just try to write all these elements. Integer I equal to 0, I less than generally 5. We are declaring that only, that much only. I plus plus. Array of I is the index of that one. This is just a one time completion it is taking. Okay. Okay. This is okay. So we are just trying to declare an array and we are trying to access that elements actually. Let us see like we compile and check it out this. Yes, we are able to print whatever elements so that array contains, right? So what we will do next is as we discussed accessing an element, right? Accessing element. Basically it will take of one time complexity, constant time. Just if you know the index, it will just trying to access it. How it will be looks like trying to access element at index example 2. Okay, what is the value will be here, right? Array of 2. So here actually index will start from 0 1 2, it should be 3. This line should print 3 actually, But this is actually, if you observe that we know the index, it is taking constant time, that is O of 1 only, time complexity. Let us see that how it works. Yes. So in the index element at index 2 is 3, right? Okay. Now how to modify an element? Okay. For example, I want to modify at index 2. I know the index of the, I know index 2 I want to modify. I will just try to change the value. That's it. Okay. If you want to access and see the same thing, at index 2, you just try to access again with the index 2 value, right? This is also like modifying an element also will take O of 1 time complexity only, right? Let us see that. I'll just go a little up here. If you see now, earlier it was 3, now it is like a 6, right? Now we are able to modify element at constant time, right? And also if you want to print these values, we can print also. Probably you want to make all elements want to print, we can do that as well. Okay. Okay. Let us see this once again so that it will be more clear what is the modified array as of currently looks like. So modified array will be like 1, 2, 6, 4, 5, right? Perfect. Now interesting thing is inserting an element. How and we can insert an element. Okay. For example, we'll try to insert an element at position 2. Okay, with new value. Insert an element at position. So for this, actually, what we need to do, we need to iterate first, and we need to make the remaining elements should be in a good position. Okay. Okay. So what we will do here is we are trying to insert at position 2. That means remaining elements we need to shift. Correct. So for what we need to do is integer I equal to 4. That means that is the position. Okay. Maximum position I greater than or equal to 2 I minus minus. So till the position 2 we need to shift all elements and we need to make 2 as a empty space for that. Array of I plus 1 equal to array of I. Okay. Now the position will be shifted from here. Now we are inserting element modifying or inserting actually new value at position 2 is 7 and 6 is shifted now to the array of 3. Okay. Let us see like how it looks like after after inserting 7 at position 2. Okay. Let us see how it looks like now. Now we have actually changed the values. So I equal to 0, I less than 6, I plus plus. Okay. C out uh, array of I C out inline. Let us see this operation actually takes O of one O of n time complexity. Time complexity could be O of n because we need to traverse all elements actually to make the position for that to insert new element. Okay. Let us see like if you observe here like 1 2 at second position you can see that 7 is inserted and remaining elements are shifted, and before that it was like 1 2 6 4 5. So after insertion this will become size 6 and new element inserted at position 2. This will take O of entangular because we need to travels from 2 to all the elements from next shift we need to do, right? Perfect. Now insertion is we know like uh, okay how to insert and why it is taking O of n time complexity. Now let us talk about deleting an element. Okay, element at position 2 again. This is also will take O of 1 O of n time complexity because we need to delete element at position whatever the x we got, and again we need to shift the elements. In this case we are planning to remove element from the position 2, right? So what we can do is we just need to travels from uh, integer I whatever the position we thought of uh, deleting, and I less than or equal to, in this case we have all elements till 5 now, actually 0 to 5, that means 6 elements, and what we can do I plus plus we can do. So here if you observe that of I equal to array of I plus 1. Okay, now we found that element is deleted. Now what we need to do is we need to remove last element actually to last element here is actually 5. We need to set to 0. Okay, now after deletion let us see that how it looks like. After deleting an element at position 2, we'll try to iterate again. Okay, I less than, currently there was 6, now it will be 5 elements, I plus plus. Basically what I'm thinking here is I need to write thing and dot index 2. Okay, we'll try to print the values array of I. Okay, let us see like insertion thing. I think we observed already that, and the deletion part also. We'll try to run this program. Now we'll see like after deletion how it looks like. You observe that after inserting position we saw this one. Now again I'm deleting at position 2. Now if you observe that there are 1, 2, 6 and 5. There it is reverting to the same array whatever it was there before. Okay. And as we discussed, the deletion also will take the of n time complexity. So as part of this, we covered using C++ how the C++ arrays operations like insertion, accessing an element, modifying an element, insertion and deletion. And also we discussed about time complexity of each operations in the array. That's all about this session. Thank you.